Flotation reagents. According to Perry, flotation reagents allow separation of the desired solid from the undesired ones by making desired materials attached to the air bubbles. There are three different types of flotation reagents. These are collectors, frothers, and modifiers. The first one is the collectors. Collectors are reagents that are used to selectively adsorb onto the surfaces of particles. They form a monolayer on the particle surface that essentially makes a thin film of nonpolar hydrophobic hydrocarbons. The collectors greatly increase the contact angle so that bubbles will adhere to the surface. Collectors can be generally classed depending on their ionic charge. They can be non-ionic, anionic, or cation. From figure 19-64 of Perry, you can see the classification of collectors. The non-ionic collectors are simply hydrocarbon oils, while the anionic and cationic collectors consist of a polar part that selectively attaches to the mineral surfaces, and a nonpolar part that projects out into the solution and makes the surface hydrophobic. The first type of collector, which is the non-ionizing collectors, are insoluble in water and cause the particles to become hydrophobic by converting them with a thin film. The most common floated naturally hydrophobic material is gold. Addition of collectors such as fuel oil and kerosene significantly enhances the hydrophobicity of the coal particles without affecting the surfaces of the associated ash-forming minerals. This improves the recovery of a coal and increases the selectivity between coal particles and mineral matter. Dosages requirements are 0.1 to 1 gram of reagent per kilogram of solids. The next type of collector is the ionizing collectors. They dissociate into ions in water and are made up of complex heteropolar molecules. Again, they adsorb either physically or chemically on the particle surface. They can also be classified as cationic or anionic, depending on the nature of the nonpolar hydrocarbon group. Examples of ionizing collectors are fatty acids, long-chain sulfates, sulfonates, amines, xanthates, and dithiophosphates. Usually, 0.05 to 0.15 pound per ton of solid is used. Always remember that the addition of excess quantities of a collector is not desirable because it results in reducing the selectivity and increasing the cost. The second flotation reagent is the frothers. It is added to stabilize the air bubbles for effective particle bubble attachment, carryover of particle-laden bubbles to the froth, and removal of the froth. It is similar to the ionizing collectors except that they concentrate primarily at the air-liquid interface. Examples of these are pine oil, crassilic acid, polypropylene glycol, short-chain alcohols, and 5 to 8 carbon aliphatic alcohols. The third flotation reagent is the modifiers. It can be classified as activators, pH regulators, depressants, and dispersants and flocculants. The activators are used to make a mineral surface amenable to collector coating. However, pH regulators are used to control or adjust pH. Examples are lime, caustic soda, soda ash, and sulfuric acid. Always remember that pH is a very critical factor in many flotation separation. Examples of depressants are sodium or calcium cyanide to depress pyrite while floating galena, sodium ferricyanide to depress copper sulfate while floating molybdenite, and lime to depress pyrite, sodium silicate to depress quartz. Lastly are dispersants and flocculants. They are important for the control of slimes that sometimes interfere with the selectivity and increase reagent consumption. Examples of dispersants are soda ash, lime sodium silicate, and lignin sulfonates. Examples of flocculants are starch and polyacrylamide.